Hello guys, welcome back to another new video. Here we go with some important and mostly asked questions in external examinations, and here we go with Unit-1 matrices. First question, we have reduce the given matrix into normal form and hence find the rank. So this is here we have three rows and 5 columns, which is of 3 by 5 matrix, and these 2 minus 5 6 are the diagonal elements. Here you need to apply the row operations and column operations in order to find the rank of this matrix, and at last it will be about to the identity matrix. Then you can find the rank from that. Next we have the questions. Solve the equation using Gauss elimination method. So in this Gauss elimination method, first write the matrix A and argumented matrix A by B. Then after reduce those two matrix into the echelon form to find its rank. Then after write the equations from those echelon form of argumented matrix A by B and solve those equations. You will get the values of Z, Y and X. So this is how we will find the solution of given system of equations using Gauss elimination method. Then next again we have the find the rank of this matrix by normal form. Here also we have 4 rows and 4 columns, which is 4 by 4 matrix. Then the diagonal elements are 2, minus 1, 3, minus 7, and make these below elements 0 and upper elements as 0 using row and column operations respectively. Then you will get reduced into this as to the identity matrix. From that find the rank. Next we have the question, find whether the following system of equations are consistent. If so, solve them. So in this solving the system of equations, here you can see the equations as this. First write the coefficient matrix A, then after write the variable matrix which is of x, y and z. Then after write the constant matrix. Here constant matrix includes the elements like 5, 1, 8. So from this constant matrix you can get to know that these equations are homogeneous type of equations, and in non-homogeneous type of equations, and in these non-homogeneous type of equations you will have the two ways of getting an answer as consistent and inconsistent. So check whether they are consistent or not. To check that, first find the rank of A, then after find the rank of A by B, which is argumented matrix. If both the matrix rank of both the matrix are equal, then those system of equations are said to be consistent. Otherwise, if not equal, then those system of equations are said to be inconsistent. So if consistent, solve this, it means they have the solution. If you get it as not equal to both, if the rank of those two matrices are not equal, then it will go into the inconsistent, then you cannot solve them. You will not get the values of x, y and z. So check whether they are consistent or not. And next we have the question here, solve the following system of equations by using Gauss-Seidel iteration method. So similar type of question I have explained in my previous video, and this question have appeared in external examination. So here you need to apply the condition as so from this equation you need to take the coefficient of x, as this coefficient of x is large when it is compared to y and z, and then 20 is greater than or equal to coefficient of y plus mod of coefficient of z. Then from this equation write the conditions. If these three equations satisfies the condition, then solve further to find the values of x, y and z. Here you get into the iteration, first iteration, or you can call it as approximation also. So you solve the problem until the two iterations are nearly equal. So here you will get the need of using calci. Calci operation is mostly used in this method. Next we'll go with one more questions here, like solve the equations using Gauss-Seidel iteration method, as I told you previously. Same here you get that 8 is greater, mod of 8 is greater than or equal to mod 3 plus mod 2, and here taking the coefficient of y, and here taking the coefficient of 12. If you take the coefficient of 12 here, you get it as 6 plus 3 9, and then 12 is greater than or equal to 9. Yes, this equation is satisfying the condition. And similarly you check the conditions for all the equations. Then you have find the rank of this matrix by reducing into echelon form. Just as I told you, now this is of 4 by 4 matrix. Minus 1 1 2 1 are the diagonal elements. Then make these below elements and upper elements as 0, using row operations and column operations. At last you will get into the identity matrix. From that find the rank of the matrix. And here you have solved the system of equations by Gauss elimination method. So Gauss elimination method, nothing but here just write the matrix A and argumented matrix A by B. So this type of equations you have seen in Gauss seidel iteration method. Anyhow you will get the values of x, y, z as same, but the using the method is different. Here you use Gauss elimination method, like first write the matrix A, then after A by B, then reduce into echelon form, then write the equations from the echelon form of A by B. Then after you solve them, you get the values of x, y and z. So using Gauss elimination method or Gauss seidel iteration method, you will get the same values. So as here they ask the Gauss elimination method, then use Gauss elimination method. Here you can see this question and these questions are similar, almost same. So you using the method is different here, but getting the solution is same. Then you have one more here question, like find the inverse of the matrix using Gauss-Jordan method. As here Gauss-Jordan method, nothing but here just find the inverse of non-singular matrix. It means whose determinant is not equal to 0. Then here use only row operations. Row operations only should be used here, and just make all the elements as 0. Here you have to write in the format of A is equals to in into A, where in is nothing but identity matrix. Here we have 4 by 4 matrix, then I4, that is of matrix identity matrix, which is of 4 by 4 matrix. Then use the formula as condition A is equals to in into A, then apply the row elementary operations. So whatever the elementary operations you will apply to the A in the left hand side, use same to the identity matrix, and at last you will get the inverse of the matrix as I is equals to B into A, and A inverse you will at last you will get the inverse of A. So that type of problem I have explained in my previous videos. Then we have the question like find whether the following equations are consistent. If so, solve them. Here also we have the 3 equations, and check whether here write the coefficient matrix, then after variable matrix, then after write the constant matrix. Constant matrix consists of these elements as 9, 6 and 3. So it is a non-homogeneous system of equations. Then check whether they are consistent or not consistent. If consistent, solve them and find the values of x, y and z. So condition you need to apply here is rank of A is equal to rank of A by B. If both are equal, then the system of equations are said to be consistent. If not, they are inconsistent. So solve this and get the values of x, y and z. Then we have the question, use Gauss seidel iteration method to solve these equations. So here one trick lies. I'll tell you that from this, if you take the coefficient of x, that is 25, and that mod of 25 is greater than or equal to mod of 2 plus mod of 2, which is true, and this equation is satisfying the condition. Then coming into the second equation, from this you need to take the y coefficient as 10, with 10 which is mod of 10 which is equal greater than or equal to mod 2 plus mod 1. Yes, 10 is greater than or equal to 3. So this condition is also satisfying. This equation is also satisfying this condition. Then from first equation you took the coefficient of x, from second coefficient of y, So from that you need to take the coefficient of z. So from, if you take the coefficient of z or y or whatever it is, then 1 is greater than or equal to 1 plus 1. So 1 is greater than or equal to 2, which is a false statement. So here you need not to apply the condition. So the condition get false. First two equations are satisfying and the third equation is not satisfying the condition. So we can tell that they are not diagonally dominant. So further you cannot solve because this equation is not satisfying. So if you write just these three statements as the just write the conditions, three conditions, then after write these equations are not diagonally dominant. So we cannot use the Gauss-Seidel iteration method to find the solution of this equation. So we cannot use, just write only those four statements, you get 10 marks for that. So here only the trick lies. So there are few people like yeah, I know the answer, and they get into the answer, but the trick lies here. Just write the four statements, you will get the 10 marks. And here we go with next problem. Solve the system of equations, these equations using Gauss elimination method. So Gauss elimination method, as I told you, that those equations reducing into a and then a by b. So as I told you previously, solve those equations and get the values of x, y and z. Then you have here, find the rank of matrix by using normal form. Then find the inverse of this matrix by using Gauss-Jordan method. So Gauss-Jordan nothing but here just finding the inverse of a matrix A. Then A is of the form A is equals to In into A. Just only use row operations, column operations should not be used. Then solve the system of linear equations by using Gauss-Seidel iteration method. Then apply the conditions. If satisfies, then solve the equations to get the values of x1, x2 and x3. Then we have this question, reduce the given matrix into normal form and find the rank. So similar type of equation, just apply the row operations and column operations. And next we have the last question here, solve the equations using Gauss elimination method. As I told you previously, write the matrix A and A by B, reducing into echelon form, write the equations from the echelon form and solve them, get the solutions of x, y and z. So here you can see overall we, in these questions which we are discussed today, you have 5 questions from normal form and 4 questions from Gauss elimination method and 2 questions from Gauss-Jordan and 2 questions from solving system of equations, that is whether they are consistent or not, that type of questions you have seen. Those are of 2 questions and 4 questions from Gauss-Seidel iteration method. So here you can see that most of the questions were repeated on normal form, Gauss elimination method and Gauss-Seidel iteration method, and at last we have Gauss-Jordan and solving the system of equations. So these topics are going to be most important, and such type of questions can maybe appeared in coming external exam. So these are the questions, practice these method problems, and if you get any queries, let us know in comment section. Thank you.